Have you ever wondered how a car engine works? It's a marvel of engineering that combines physics, chemistry, and mechanical design to move you from point A to point B. Engines are the beating heart of every vehicle, a sophisticated piece of machinery that converts fuel into motion. Now, not all engines are created equal. There's a wide array of engine types, each with its own unique characteristics and advantages. First, there's the inline engine, where cylinders are arranged in a straight line, commonly seen in most economy cars. Then, we have the V-type engine, known for its power and smoothness, often found in high-performance and luxury vehicles. Lastly, the boxer engine, with its horizontally opposed cylinders, offers a lower center of gravity and is a favorite in sports cars. Engines are complex, intricate, and absolutely fascinating. So buckle up, because we're about to take a thrilling ride into the world of engines. Stay tuned as we delve deep into the heart of a car, its engine. To understand how a car moves, you first need to grasp the basics of its engine. Think of the engine as the heart of the car. It's a complex machine with many parts, each with a unique role to play. Let's take a look at some of these key components. First, we have the cylinders. These are essentially the engine's chambers where gasoline is transformed into power. The more cylinders an engine has, the more powerful it generally is. Inside each cylinder, there's a piston that moves up and down, compressing the air-fuel mixture and extracting energy from it. Next, we have the intake and exhaust valves. These are like the gates of the engine. The intake valve allows the air-fuel mixture to enter the cylinder, while the exhaust valve lets out the exhaust gases after combustion. Then there are the spark plugs. These little devices ignite the air-fuel mixture inside the cylinders. When the spark plug fires, it creates a spark that ignites the mixture, causing a mini explosion that pushes the piston down. Finally, we have the crankshaft. This is what converts the up and down motion of the pistons into rotational motion that ultimately drives the wheels of the car. It's like the engine's main artery, transferring energy from the pistons to the rest of the vehicle. Each of these parts has a specific role, but they don't work in isolation. They're all interconnected, working together in a finely tuned dance. The cylinders, pistons, valves, spark plugs, and crankshaft, they all rely on each other to function properly. If one part is off, it can affect the performance of the whole engine. So, you see, an engine is not just a jumble of metal parts. It's a marvel of engineering, a symphony of moving parts working in perfect harmony. It's what makes your car more than just a hunk of metal. It's what makes it alive. These parts work in harmony to make your car move, but how do they do it? Let's find out. The magic happens in 4 stages, also known as the 4-stroke cycle. Imagine a delicate ballet, but instead of dancers, we have air, fuel, and a spark, all performing in a tiny cylinder. This ballet is what powers your car, and it's choreographed in 4 distinct steps: intake, compression, power, and exhaust. First up is the intake stroke. This is when the piston starts at the top, the intake valve opens, and the piston moves down to let the engine take in a gulp of air, which carries a droplet of fuel with it. It's like a deep breath before the plunge. Next comes the compression stroke. The intake valve closes, and the piston moves back up the cylinder, compressively squeezing the air-fuel mixture. This is akin to packing a snowball, making it ready to fly. The tighter the squeeze, the more powerful the potential energy. The third step is where the real action happens. We call it the power stroke. The spark plug fires, igniting the compressed air-fuel mixture. This mini explosion pushes the piston back down, providing power to turn the crankshaft. It's the release of the snowball, the moment of impact. Lastly, we have the exhaust stroke. Once the piston reaches the bottom of its stroke, the exhaust valve opens. As the piston returns to the top, it pushes the exhaust gases out of the cylinder. It's like the sigh after the throw, the release of expended energy. Then the cycle starts all over again. The intake valve opens once more and the piston moves down to pull in a fresh gulp of air and fuel. This cycle repeats over and over, thousands of times per minute in every cylinder of your engine. It's a symphony of mechanical precision, a dance of metal, fire, and air. Each stage of the cycle is critical, and they all need to work in perfect harmony for the engine to run smoothly. It's a constant dance of precision and power, all taking place in the blink of an eye. The unsung heroes of this process are the spark plugs and valves. Let's break it down and understand their roles. First up, we have the spark plugs. These little devices might seem insignificant at first glance, but they're vital in the engine operation. During the combustion stage of the 4-stroke cycle, The spark plug ignites the fuel-air mixture, creating a mini explosion. This explosion generates a force that pushes the piston down, which turns the crankshaft and ultimately drives your wheels. It's a tiny spark, but it's the spark that powers your journey. Now let's talk about the valves. Specifically, we're referring to the intake and exhaust valves. These valves are like the gatekeepers of your engine, controlling the flow of the fuel-air mixture and exhaust gases. The intake valve opens during the intake stroke, allowing the fuel-air mixture to enter the combustion chamber. It's like opening the door for a guest. In this case, the guest being the fuel-air mixture. Then, as the piston moves up, compressing the fuel-air mixture, both valves close, creating a sealed chamber for the ignition. It's akin to closing and locking the door, ensuring that the energy from the upcoming explosion is effectively utilized. Following the explosion, the exhaust valve opens during the exhaust stroke, allowing the exhaust gases to escape and make room for a fresh charge of the fuel-air mixture. It's like opening the door again, but this time to let out the guest who's overstayed their welcome. So you see, spark plugs and valves play an essential role in the grand symphony that is your car's engine. They might not be the biggest or most noticeable parts, but they're certainly among the most crucial. They're like the conductor and musicians in an orchestra working in harmony to create the magic of movement. Without these components, the four-stroke cycle would be impossible. Now, how does all this result in motion? Well, you're in the right place to find out. It starts with the up and down movement of the pistons. This linear motion, as it's called in the mechanics world, needs to be converted into something the wheels can use. And that's where the crankshaft comes in. Imagine a seesaw, but instead of two seats, there's a wheel at one end and a piston at the other. The piston, when it moves down, pushes the wheel up, and vice versa. This is essentially what the crankshaft does. It's a long metal bar with several seesaw-like points or journals along its length. Each journal is connected to a piston. As the pistons move up and down, they rotate the crankshaft, transforming their linear motion into rotational motion. But we're not done yet. This rotational motion needs to reach the wheels, and for that, we have the transmission. The transmission is a complex system of gears that adjusts the speed and torque, or turning force, from the engine to the wheels. When you shift gears, you're actually changing the gear ratio, which alters the amount of force that's transmitted to the wheels. For example, a low gear ratio provides more torque but less speed, ideal for uphill climbs or pulling heavy loads. On the other hand, a high gear ratio gives you more speed but less torque, perfect for cruising down the highway. Now the power from the transmission is delivered to the wheels via the drive shaft and the differential. The differential is another set of gears that allows the wheels to turn at different speeds, like when you're taking a corner. So there you have it. The pistons push the crankshaft spins the transmission adjusts the power, and the differential delivers that power to the wheels. Each step is a beautifully choreographed dance of metal and motion, all happening in the blink of an eye. This is what makes your car move, with each component playing a crucial role in the process. Remember the engine types we mentioned earlier? Let's dive into their differences. First up, we have the inline engines. They're called this because the cylinders are lined up in a row. This simple, compact design makes them cost-effective and perfect for smaller vehicles. But they can't accommodate more than 6 cylinders without becoming too long and unwieldy. Then there's the V-type engines. Picture 2 inline engines forming a V shape. They can house more cylinders, making them powerful and ideal for larger vehicles. However, their complex design makes them more expensive to produce and maintain. Finally, we have the boxer engines. Their horizontally opposed layout reduces vibrations, providing a smooth ride. They're also low to the ground, improving vehicle stability. But they take up a lot of space and are more costly to manufacture. Each engine type has its unique characteristics, but they all follow the same basic principles.